Okay, so they want us to find the inverse of this function. This one's going to be fairly challenging. It's the same steps, but a little more challenging than normal. So step number 1, switch or invert x and y. So where's y? This is y. The function values are the y's. So it's going to switch, and it's going to switch with both of those. That's what's harder about this one is we have the x in 2 spots. It's going to switch with both of them. So it'll become y on the outside. No, wait a minute. That's what it was. X on the outside because they're switching, right? It was y. Now it's x. And then the other 2 x's both become y's. Like so. Good so far? So I just, again, switched x and y. Everything else stays put. I just invert. That's what an inverse function means, is a trading of x's for y's and y's for x's. Everything else stays put, okay? And then step 2, solve for y. Now, this time solving for y is a little more tricky. Why? Because it's in 2 places. So let's put this over 1. Remember whenever you have a whole number or whole letter interacting with a fraction, put it over 1, make it look like a fraction, and then go diagonal, diagonal. And so what do we get? Minus, the x times minus 3y minus 2 equals 1 times minus y minus 5. Is that good so far? Diagonal, diagonal. Okay, now we distribute. Boom, boom, right? This x multiplies this minus 3y and this minus 2. So you get minus 3xy minus 2x, and then the 1, boom, boom. That's going to look like nothing happened, minus y minus 5, because they were just multiplied by 1, and 1 doesn't change anything. All right, we good to there now? Let me make it more clear with the wall separation here. Okay, so now this is where I want to help. So notice we're trying to solve for y. Y is in 2 places. Do you see that? Right here and right there. Y is in 2 places. What do you do when what you're trying to solve for, y, try to solve for y, not x, right? Y is in 2 places. Y is in 2 places. What do? You get the y's on the same, so step number 1, get the y's on the same side. Step 2, factor, let me say out. Factor out y and divide. Okay, so let's do it. Let's get the y's on the same side. How do you do that? How do you get the y's on the same? What are we talking about? Well, just grab this minus y and jump him this way. And grab this minus 2x and jump him the other way. What happens when anything jumps over the equal sign? It changes signs. The sign in front of it changes, right? So it'll become minus 3xy plus y. See how that minus y became plus? And then the other side, plus 2x minus 5. You see what happened there? Now let me I just did a shortcut, and that's great, but I want to make sure you understand why that's really true. See, if I added y to both sides, that would cancel this out. And if I added 2x to both sides, that would cancel this out. Just so see why it's a plus y on the left and a plus 2x on the right? That's just what's true, right? If you added y to both sides and added 2x to both sides, that would cause what I'm saying to happen. So by way of a shortcut, so just so you don't have to do that step every time, a shortcut is just jump it. Just jump. This guy just jumps to the other side. And when he does, he changes the sign in the front. Really, you just added y to both sides, right? Got rid of this one, and it became a positive y on the other side, because you always do the opposite to get rid of anything. That's why it's opposite on the opposite side, opposite sign on the opposite side. Same thing with the minus 2x. How do you get rid of it? Add 2x. Whatever you do to one side, you have no choice but to do the other. So it cancels out here, ends up the opposite plus 2x on the other side. Okay, that's what happens. So to save time, just jump these guys. Don't just skip this adding to both sides, subtracting from both sides stuff, and just jump. Let that minus y jump over, becomes a plus y. Let that minus 2x jump over, becomes a plus 2x. Okay, so now what are we trying to solve for? They want, well, y, right? Solve for y. How can I solve for y? Well, careful. Step number one, get the y's on the same side. They are. See the y here and the y there? See how those two y's are on the same side? That's what I did there. I got the two y's on the same side, and then step two, factor out y. In other words, like this. Have you seen this before? Are you tracking with me? See what's happening there? If I was to take that y and multiply, see, I'd go right back. That'd be minus 3xy. And y times 1 would be y, wouldn't it? So I just factored out the y because they both had a y. That's why I got the y's on the same side, because they both had a y. Then I could factor out the y. Remember, I'm trying to solve for y here. This is all about solving for y. Now, can you see what you do? It just says, now you divide. So divide by the minus 3x plus 1. And these cancel. And so there it is. Y is alone. What does y equal? 2x minus 5 over minus 3x plus 1. Y is alone. So that's an important, and that's our answer. We're done. That's the answer we put in right there, because that is the function. So one more time, let me recap, and then let me show you some alternate versions of the same answer, which really tricks a lot of people on multiple choice exams, and I don't want to trick you. I want you to learn this stuff and ace it. So let me make it clear. So first off, what did we do? Well, in a sense, we did what we always do for inverse functions. Same two steps, just the second step was a lot harder than normal. You switch x and y, so this y became an x and these x's became y's. Here we go, right there. And then we solve for y. So these are the two steps you always take when you find an inverse function. Step one, switch x and y. Step two, solve for y. So I switched x and y, and now I'm solving for y. So I cross multiplied. I got this, distributed, got that. And then right here, I noticed that I have a y there and a y there, two places. And so when the y is in two places, what do you got to do? You've got to get the y's on the same side, factor out the y, and divide. So I took these two y, I took this y term and jumped it over here next to the other y term. So minus 3xy and plus y, when that minus y jumped to the other side. And then the minus 2x jumped over, became a plus 2x like that. Then factor out the y right here and then divide. There you got it. Now, what are the, I'll say, or, do you realize these are the same? Or you could have the answer 2x plus 5. This way. That's the same answer. Do you see that's the same? You might think, no way, Ms. Taryn. Yeah, no, that's the same answer, because you could take that minus and you could go to the bottom and it could hit both of these. And what would it then become? 2x plus 5 over minus 3x plus 1, same as that one. See that? So you might say, well, you can do the minus in the bottom. Yeah, right. With a fraction, you can do either one, but not both. Are you clear on that? In other words, if I go negative 1 over 2, or I go 1 over negative 2, or I put the negative in the front, those are all the same. In fact, let me do it the other way. If I put the negative in the front, that's the same as top only or bottom only. They're all three the same, aren't they? Front, top, or bottom. It doesn't matter. It's a negative half, however you do it. So notice when you're on the front, you can go to the top if you want or the bottom if you want. So I'm on the front here. You can't, oh, by the way, it's not the same. You can't go to both, right? It's not the same as two negatives which would be positive, right? So when you have a negative in the front, you can go to the top only or the bottom only, but not both. So, okay, so then with this minus in the front, I'm saying that minus in the front is the same as if you took it to the bottom only or the top only. If I take it to the bottom only, it becomes minus 3x plus 1, clearly it's the same. So then you're saying, you might be thinking, well, then, Mr. You're saying, or you could let the, you could do the minus on the top, minus 2x plus 5, and leave the bottom as it was. You could let this minus go to the top. Yep, that's the same. That's, this is the same. This is the same. Those are all the same. You can also trade the order anytime you want. You aware of that? So in other words, let me bring this answer down here again. I'm giving you a million different looks. This is part of learning the language of algebra, is knowing when two things that look different are really the same. That's an important skill. So I could say 2x minus 5 again, minus 3x plus 1. That was the first one. Or, you know what you could do? You could swap the order. You could write this 1 minus 3x. Why? Because the signs are the same. The 3x is negative, the 1 is positive. Same signs, order doesn't matter. Order does not matter. Let me add some room there so you can see that. There we go. Order does not matter. Same signs. What do you mean same signs? It's a negative on the 3x. It's a negative on the 3x. Signs are in the front of a letter or number. Positive on the 1. Nothing's in front of this one, which makes it positive. Yeah, so those are the same, aren't they? We all seeing that? The order doesn't matter. Signs matter. Order doesn't. Or you could let the negative go to the bottom or let the negative go to the top instead of being in the front. It's all the same. Those are all the same. So it's important to know those different varieties.